Hello YouTubers, I am the Celtic Engineer, and today we're going to talk about the SF-2 humidity sensor made by Celtic Engineering Solutions. That's this board right here. The actual sensor itself is this small black chip, and on the board you'll find two jumpers. This helps set the I2C address. When you get the board, the jumpers should be open so that they're going to be pulled up. So you'll have two ones that will set the address in the code. And there are five wires that connect to the board. The first one is power. In this case, we're connecting to 5 volts. Then there's SDA and SCL, and that's part of the I2C interface. The next wire will be the alert or the interrupt, which goes to digital port 2. And then finally there's the ground. Now on SDA and SCL, unless you're really close, like this close, you'll probably want to have these two resistors, pull-up resistors on there. Start with about a 5K resistor for I2C. As the distance between the Arduino and the sensor board gets longer and longer, those resistors will become important, and you may have to lower the resistance to get a stronger pull-up. Okay, so let's go ahead and take a look at the interface. So the code is on the right. I've already gone ahead and loaded the code onto the Arduino. What you'll see when you load this is on your serial monitor, which we've set at 9600 baud. It says humidity sensor SF-2. And there's a number of things that you can do. The first one, and you'll want to do this right away, is to write to the configuration register. And that configuration register is on this little temperature or humidity sensor chip. And what that does is it puts the chip into a known state. It's going to tell the chip that when we ask for data, we want both temperature and humidity. We want the resolution to be 14 bits. There's a heater on the chip. We want to turn the heater off. You may choose to turn that on. That's up to you. But it'll come default as being off. So let's go ahead and do that. I'm going to write a 1 and hit return. Configuration register has been updated. And then you can always go ahead, and option number 2 is to read the configuration register. If you start changing the code, using number 2 to make sure that you're getting the bit set that you want is important. So if you type in number 2, this is in binary, and you can go ahead and pull up the data sheet on the chip, the humidity chip that's on the board, and you can look at the configuration register and decide how you want to set it up for your case. So then the next thing we can do is let's actually take a measurement. We've got this set up as a one-shot, so we're going to go ahead and request the temperature and humidity by typing in number 3. And it says that it is about 20 degrees Celsius and 68 degrees Fahrenheit, and the relative humidity is about 42%. So there's a couple of other things that this code allows you to do. Again, this is just example code to show you what you can do. I fully expect that you'll rewrite this to fit your needs, but each chip comes with a manufacturer's ID, so we can go ahead and just take a look at that. I believe that it will always read 5449 because that is the manufacturer of the chip. That's their number. Number 5 is the device ID. Number 6 is a unique serial number for each chip that they make. And that's the number that this particular chip is. You can compare that to yours and see that they're different. If you get playing with this and you get lost, you get a lot of information on the page. You can go ahead and hit H, or which stands for help, and it'll bring that menu back up. You can also clear the page, hit H, and I've got to be in that window, hit H, and you'll get back to your main menu. I hope this helps you get a jump start on using the firmware, the example code that comes with the board. You can get the board on Celtic Engineering Solutions website store, or you can get it off of Tindy. I hope you have fun. Have a good day.